Every few years, a new programming trend comes along that promises to fix everything wrong with software development. A few years ago, that trend was functional programming. It was supposed to make our code cleaner, safer, and easier to reason about. But after a decade of hype, most developers who've actually tried it quietly admit the same thing. Functional programming kind of sucks. And here's why. On paper, functional programming sounds like a dream. No side effects, no mutable state, no bugs caused by hidden changes. Just pure functions, mathematical beauty, and perfect predictability. Languages like Haskell, Scala, and even JavaScript's new functional style promised a cleaner future. But in practice, it's often frustrating, unreadable, and completely detached from how humans actually think about building systems. The theory is elegant. The reality is painful. Reason 1. It's elegant until you actually have to ship something. Functional programming loves to talk about purity and immutability. That's great in academic papers, but in the real world, software interacts with messy things. Files, networks, users, databases, APIs. You can't stay pure for long. In FP, you end up jumping through hoops to do something simple like reading a file or updating a record. You wrap side effects in monads, thread data through layers of functions, and write more boilerplate than the Java code you were trying to escape. As one engineer joked, I spent 3 days learning how to print "Hello World" without breaking purity. Reason 2. It's impossible to onboard new developers. Ask any hiring manager who's tried to run a Haskell team. It is nearly impossible to find developers fluent enough to be productive. And even if you do, the learning curve is brutal. FP introduces vocabulary that sounds like it came from a math textbook. Functors, monads, higher-order functions, currying, algebraic data types. It scares off newcomers before they even start typing code. In theory, FP makes code easier to reason about. In reality, most teams spend more time reasoning about the reasoning. Reason 3. Readability takes a beating. Functional programmers love short, expressive one-liners. But there's a fine line between concise and cryptic. When your entire application is a chain of anonymous functions, lambdas, and maps, it might look clever until you have to debug it at 3 a.m. A single pipeline of transformations might be pure, but it's also unreadable to 90% of your colleagues. Good code should communicate intent. Functional code often communicates intelligence. Reason 4. The real world isn't functional. At the end of the day, software runs on hardware that's inherently imperative. CPUs don't execute pure functions. They change state billions of times per second. Forcing every real-world problem into a purely functional box often feels unnatural. FP languages spend enormous effort pretending state doesn't exist, even though the entire universe and your application runs on it. It's like trying to cook dinner without ever touching the stove. Reason 5. The industry moved on without it. In the early 2010s, FP was the buzzword at every tech conference. Today, it's barely mentioned outside of niche circles. Why? Because mainstream languages took the good parts of functional programming, immutability, higher-order functions, map-reduce patterns, and blended them into practical ecosystems. Java, C#, Python, Kotlin, and JavaScript all became a little functional while staying usable. The pure FP languages never went mainstream because they demanded perfection from imperfect humans. The irony: functional ideas still win. Here's the twist. Functional programming itself might suck for most teams, but its ideas didn't die, they evolved. Modern architectures like React, Spark, and even serverless computing borrow heavily from FP concepts. We don't need to write everything in Haskell to appreciate immutability or composability. We just need balance. A mix of functional ideas with pragmatic design gives us the best of both worlds. Conclusion: programming is about people, not purity. The biggest problem with functional programming isn't syntax or theory, it's attitude. Too often, FP turns into a religion about purity instead of a tool for progress. Developers don't need mathematical perfection. They need code that ships, scales, and can be understood by the next person on the team. So yes, functional programming sucks, not because it's wrong, but because it forgot who it's for. Don't forget to subscribe, and hit the notification bell for more honest takes on software, AI, and the ever-changing world of technology.